Hello students, welcome back to our online class. Students, take out your social science book. Today we'll just start a new chapter, that is chapter number 3, motions of the earth. Okay, so take out page number 102. The ancient people had always observed the movement of the sun, the moon and the other heavenly bodies in the sky. They believed that the earth was stationary and other heavenly bodies moved around it. So what happened? The ancient people, they believed that earth is not moving, but all other heavenly bodies are moving. That is the sun, the moon, the stars, all these are moving except the earth. Nicholas Copernicus, a Polish astronomer in the 16th century, was the first to say that the earth would not only appear to be stationary. Actually, the earth not only spins on its axis but also moves around the sun. And it was only Nicholas Copernicus, okay, then who was an astronomer. He was the first person to say that earth not only spins on its axis, but also moves around the sun. Okay, thus the earth has two types of motions. The movement of the earth on its axis is called rotation, and the movement of the earth around the sun is called revolution. Now the earth has two motions. Number one is rotation, number two is revolution. Now what is rotation and revolution? The earth used to rotate. This is called rotation, and the revolution means the earth used to revolve around the sun. This is called revolution. The earth revolves around the sun and it also rotates. Okay. Rotation of the earth. The earth rotates on its axis from west to east. Now this is the earth. It rotates from west to east in this way. The axis of the earth is an imaginary line which passes through its center. Now which is the axis of the earth? This is the axis of the earth. Okay, this is the axis of the earth, that is from North Pole to South Pole. So it is an imaginary line which passes through the center of the earth. The axis is not vertical. It is inclined at an angle of 66.5 degrees. So the axis is not vertical, is not it? Now this is inclined. This is the meaning of inclination. Okay, slightly bent. It's called inclined, and it is inclined at what degree? 66.5 degrees. With the plane of the earth's orbit. Now what is the plane of the earth's orbit? Now this is the plane of the earth's orbit. This is the plane of the earth's orbit. See, this is the plane of the earth's orbit, is not it? So it is inclined towards the plane of the earth's orbit. This is known as the inclination of the earth's axis. Inclination is always in the same direction, that is towards the pole star. We usually used to see in the sky the pole star, that is the biggest star, which is the brightest star, is not it? Now where this by that only we can estimate the pole star always can be seen at the inclination of the earth's axis. That means the star will be not here, the pole star will be always here. Okay, to that point, clear? Every morning we notice that the sun rises in the east, travels across the sky during the day and finally sets in the west in the evening. This is due to the rotation of the earth. Now we notice everyone knows the sun rises in the east and sets in the west. But this is not due to the rotation of the sun. This is due to the rotation of the earth. Okay, this is due to the rotation of the earth. It is not the sun but the earth who rotates. Suppose we are traveling in a train. We see through the window that the trees and telephone poles on the wayside seem to move past in the opposite direction. We know that it is the train that is moving and not the objects outside. In the same way, it is the earth that is moving and not the sun. Suppose there now an example has been cited over here. Suppose we are traveling in a train, then when the train is moving, it seems that the trees and the light poles, the telephone poles, all these are also moving, but it is wrong. But we know that the only train is moving, and in the same way that the sun is moving, moon is moving, is not it? Because sometimes it disappears, sometimes it appears, is not it? But it is not the sun or the moon is moving, it is only the earth is moving. The Earth takes 24 hours or 1 day to complete one rotation on its axis. Thus, rotation is also called the daily motion of the Earth. The circumference of the Earth at the equator is 40,000 km. The Earth covers this distance in 24 hours. The circumference means the whole circle. Okay, whole circle is called the circumference. Suppose the Earth started to rotate over here and it have to complete the rotation in here. So it takes 24 hours to complete one rotation, that is 1 day. And it has to travel, that is the whole circumference is 40,000 km. Okay, here from point here to here it is the circumference it used to rotate. Okay, then this is 40,000 km. Now let's come to effects of the Earth's rotation. It makes us feel that the sun, the moon and the other heavenly bodies move from east to west. Now the Earth makes us feel that all the heavenly bodies are moving, that is the sun, the moon, the stars, is not it? So these things are moving. It seemed to us in this way, but it is not the case. Only the Earth used to rotate and revolve. It causes the bulging of the Earth at the equator and flattening at the poles. That means we have already discussed in the previous chapter that it is flattening in the poles, that is it is flat in the poles and it is bulging in the equator. Clear? Because the Earth is not fully spherical due to the bulging at the equator and flattening at the poles. Flattening at the pole means it is flat. This area is flat in the poles. It causes day and nights on Earth due to the rotation it causes day and night. Because sun remains constant, it is the Earth who rotates. Suppose this side is facing day, is not it? Now when it rotates and this side will come here and this side will go there, then this side will be facing day and this side will be facing night. It gives us the concept of direction based on the sunrise and sunset. Now sunrise, the sun rises in the east and sets in the west. The sun rises in the east and sets in the west, and by this we know the direction. It causes deflection in the direction of winds and ocean currents. Now what is the deflection mean? What is the meaning of deflection? Deflection means bend abruptly downwards. That is the direction of the winds and ocean currents used to flow downwards. Okay. It gives us a day of 24 hours. Everyone knows that in a day we have 24 hours. It causes tides twice a day. Because of this rotation, we have tides at least once a day. We have tides. Now, do you know what is the meaning of tides? I mean, high tides and low tides in an ocean current. Is not it? The water used to flow. The tide, high tide. The waves. Is not it? The waves. So it causes tides at least twice a day. The direction of the rotation of the Earth is anti-clockwise at the North Pole and at the equator. Now direction of the rotation of the Earth from west to east. In the North Pole, that is the upper pole, and in the equator. Okay. The circle of illumination. The sun is the main source of heat and light for the Earth. Everyone knows sun gives us heat and also the light. Due to the spherical shape of the Earth, only one half of it gets light from the sun at a time, and the other half remains in the darkness. Because it is spherical, because it's not, it see now this is spherical, this is spherical in shape, and because of this sphericalness, when the Earth faces towards the sun, this area gets light from the sun and this area becomes dark. And when this area will face to the sun, this area will get light and this area will have darkness. The circle of illumination is an imaginary line which separates the lighted part of the Earth from the dark one. Now what is the circle of illumination? Circle of illumination is the imaginary line. Now which is the imaginary line? Imagine this is the imaginary line, that is the which causes day and night. Okay. Which separates the lighted part, with the dark one, and this line is called the circle of illumination. Thus, the portion of the earth that receives sunlight experiences day, while the portion which is in darkness experiences night. Let us try to understand how days and nights are caused with the help of an activity. In a dark room, place a globe in front of an electric bulb. Switch on the light. You will see that the half of the globe is lighted while the other half is dark. Mark a point A in a dark portion of the globe and now rotate the globe on its axis from west to east through 90 degrees. Point A will turn towards the sun and will get some diffuse light. Now what they are trying to say in this example, you can experiment in home. Take one bulb and take one ball. Okay, in a dark room you take one ball and take one bulb. Okay, now this bulb, this is the bulb, this is the ball. Then if the bulb is facing to the ball, this one is not it. Now this area will get light and other will be remain dark. Why? Because the bulb, it's a small bulb. Okay, it's not that high powerful bulb. Then this area will get light and that area will get darkness. But suppose if we rotate, okay, if we rotate from west to east, okay, if we rotate from west to east, then this area will come here. Then the bulb is in the same way. You think the bulb as the sun, then this area will get light and that area will remain dark. This is the experiment which can do in our home only. We normally notice such light before the actual sunrise. This is called dawn. Now when is dawn? See, suppose the sun will rise at 5, okay, 5 o'clock. And then before rising, okay, it will rise. It will not directly go like this. It will come in this way. Then what happens? It will get some diffuse light. Before morning, that particular time is called dawn. Rotate the globe further from west to east. Again, further from west to east, that means you will notice A has sunrise. After we rotate the globe a little bit again, then we'll get full sunrise. Again we'll rotate, then on further rotation of a globe, A we face the bulb. At this point no shadows are noticed. This is noon time. That means if we again rotate the globe and the portion which will facing the sun, this will be called the noon time. That is afternoon. Okay, that is a midday. As we continue to rotate the globe, we will notice darkness approaching. Again it will go far away from the bulb. And again that means it is about to become dark, which we call dusk, is not it? In Assamese we used to call Godhuli. When A reaches exactly opposite side of this bulb, it is midnight. Now see, again from the west to east, again it went to that side, but the bulb is this side. So this will the point A will be facing night time. Okay, now length of day and night. We notice that the length of days and nights is not the same throughout the year. This variation is due to the inclination of the Earth's axis. Due to this inclination, the northern hemisphere remains inclined towards the sun for half of the year and the southern hemisphere during the other half. Now what they meant to say that now we know that we don't have equal length of day and night. Sometimes days are shorter, the nights are longer. Is not it how? Because this is due to the inclination of the Earth's axis, because of the tiltation part. This is called tiltation part. Is not it? Is the tiltation part. That is why. So this is the diagram. See, suppose this is the sun, is not it? Now this is the sun. This is northern hemisphere, then this is southern hemisphere. Though this is the circle of illumination and this is the inclination of the Earth's axis. Then what? This is also northern hemisphere bulb, is not it? This is the northern hemisphere. So what happened? This portion remains, only this portion remains, so have sunlight throughout the half year, and in the southern hemisphere during the other half. Figure 3.6a, the north pole is inclined toward the sun and the south pole is turned away from the sun. Thus, a larger part of the northern hemisphere receives sunlight. This results in longer days and shorter nights in the northern hemisphere. It is the reverse in the southern hemisphere during this time. That means it's meant to say this portion is receiving full sunlight. That is why this portion will be having longer days, and as a result this is southern hemisphere inclination, is not, this is the inclination part, is not, this is up to here it is inclination, but this portion, so it will be having it will be facing darkness more. Now this northern hemisphere will be receiving longer days and it will receive shorter nights. But it is reverse in the southern hemisphere during this time. Why? But this time only it is reverse. Reverse means the opposite. That is in figure 3.6b. The southern pole is inclined towards the sun and the north pole is turned away from the sun. Thus a large part of the southern hemisphere receives sunlight. This results in longer days and shorter nights in the southern hemisphere. It is the reverse in the northern hemisphere during this year. Now you observe this diagram. Okay, now you observe this diagram. Here see this north pole. Now this north pole, okay, now this is the inclination part. This is the inclination part. That means this is now this south pole is receiving this. Now this is the up to here inclination part, is not it? Now this portion is receiving much more sunlight. That means it is having longer days in southern hemisphere and shorter days in northern hemisphere. Clear? Throughout the year, the length of days and nights is equal. At the equator, it is of the 2 hours each. What would happen if the axis of the earth was vertical? The length of the days and nights would be equal, 12 hours each at all places and on the earth throughout the year. Now, what it talked now, this it is said that suppose this inclination is not there and suppose this axis will be, suppose the axis was straight, that is vertical, then each will be having 12 hours each. Got it? Now regarding the evolution of the earth, I shall teach you in the next class. Till then, thank you.